All right, welcome to part 2 of project estimates, and in this video I'm going to talk about estimating techniques. All right, so project estimates, what are they? Like I said before, this is a quantitative assessment of the likely amount or outcome of a task, and it's usually applied to costs, resources, and duration. And the reason I'm reminding you again this one is because I need to explain this before I go into the next part, okay? Which is what kind of techniques can we use? Now, there's many techniques available out there, but typically we should, if you work for an organization, just use the one that your organization typically uses or wants. That's normally how I go. If it ain't broken, don't try to fix it, right? That's my approach to it. So what kind of tools do we have? Software simulations, vendor bid analysis, group decision making, reserve analysis, cost of quality analysis, expert judgments, analogous projects, bottom-up analysis, three-point analysis, parametric models, and there's many more. I'm not going to cover all of them. I'm going to cover the three that I typically use the most, or the three that typically projects use the most. One of them is analogous estimate. What does analogous mean? Analogous means comparison with something similar. So we estimate, we make our estimates based upon the actual cost of a similar project or of a similar task. And this is should normally be done by someone who's an expert matter expert, someone that understands these type of tasks, because they might have input about the differences. No two projects are exactly the same, so you need their expertise to input the differences so that your estimates are more reliable. So this is a good approach if your detailed plan is not yet complete, but you already need to come up with estimates as quickly as possible. But just make sure that the project task is indeed similar, not just in appearance. Okay, sometimes tasks seem like they are similar, but you have to dig a little bit deeper to make sure that they are indeed similar to each other, not just look similar. The bottoms-up technique, on the other hand, is based upon the division of tasks into smaller tasks. And that means we're going to work with our work breakdown structure like we've seen it before. That's why I covered it. Smaller tasks are easier to estimate than bigger tasks. And the advantage of this is that the accuracy will be much higher for the whole project if we start by estimating the small tasks. And obviously the problem is that it's going to require much more effort. So what it will look like, you have, for example, small work breakdown structure there. What we would do for subsection 1 here, okay, would be for each one of these tasks, okay, for example, oh, this one will take 2 days, this one will take 1 day, this one will take 2 days and 2 days. And if I estimate each one of them individually, then my subsection 1 will be much more accurate in terms of estimate, because it would be 2 plus 1, 2 plus 2 plus 1 plus 2. So that would be 7 days. And I do that for all the small tasks, and at the end I would get a total that would be, for the whole project, that would be much more reliable than if I just try to predict the whole project from a general perspective. The third one is called the three-point estimate. Now, this is something that is, I like it personally and I use it quite a lot, but it does take a little bit more time. So we create 3 estimates for each task, and basically those estimates are based upon analogous or a parametric model. Okay, so you cannot just immediately use this one. You need to have some idea of what you're doing in terms of the task. So you create, first scenario is called the best case scenario, a B. The second is called the most likely case scenario, and it stands between the best and the worst case scenario. And the last one is obviously the worst case scenario. Now, to remember the 3 estimates, I put them in this order because this way it spells BMW and it's easy to remember. You associate with the car manufacturer and you will always know the 3 estimates you have to do. Then there's 2 ways of calculating. So I come up with these 3 values. Which number should I actually use? Should I use the best case scenario, the most likely, or the worst case scenario? Well, that estimate would have a lot of mistakes, would have a lot of risk incorporated into it. So there are 2 different calculations. The first one is called a triangular estimate, and it's basically an average. You do the average of the 3 values, and then you would use that as your estimate for either effort or money. The second one, which is the one I typically use, is called the PERT estimate, which is best case scenario plus 4 times the most likely case plus the worst case scenario. And why do I prefer this one over the previous one? Because in the triangular estimate, you are giving the same importance to the best case scenario, to the worst case scenario, and to the most likely. But if it's the most likely, shouldn't the most likely have a higher degree of importance on the calculation? And that's why I like estimate, because it gives a higher degree of importance to the most likely case. As an example, if I have, for example, best case scenario is 10 days, most likely 18 days, worst case scenario 20 days. If I use the triangular approach, I do the calculation and I'll get the value of 16, and that's the value I would use on my calculations. If I used a PERT value, I would get 17. So typically for most tasks, it would be quite close to each other, but like I said, I normally prefer to use the PERT analysis. Parametric model estimates are very commonly used as well, but I'm not going to go into detail on this course here. Why? Because this is what basically happens is, based upon project characteristics, we use them as input, and we input them into a mathematical model that will predict the amount of effort or the amount of costs that we're going to need for our task. And the model can be simple or it can be extremely complex. And simpler models are easy to create. We can even use an Excel sheet just to create them, but more complex models sometimes demand that we use, for example, experts like mathematicians or statisticians to help us create those models. So the accuracy of the model will depend on a couple of things. First, it depends on what historical data do you have available. How many projects similar to this have you run in the past? The more you have, the more accurate your model will be. Second, what the model gives you, can it be easily quantifiable? Can it be put into a number, or does it give you more of a degree, a range, for example? And third is the scalability of the model. Does this model work for small projects, or would it also work for a project that is 10 times bigger? And that's a big question, because as the project grows, then the level of complexity will also grow. So to summarize, we see that there are many different techniques we can use. Normally the ones I use are, for me, the favorite techniques to use is the triangular calculations, the triangular estimates to tasks, and I use as well the bottom-up technique. I think those two are quite simple to use for most projects, and as long as they don't become extremely complex, those are the two tools that I use 90% of the projects that I do. Thank you very much for watching, and I'll see you on the next video of this mini series. Let me know if you have any questions on the comment section.